What you see on the screen is the CANSIM table, labor force survey estimates by sex and age group, seasonally adjusted and unadjusted. Below the CHAS Data Center banner at the top, there are three parts: the table header, the left-hand sidebar, which has more information about the CANSIM table and some other options, and the data display section, the main part of the screen. Starting with the left-hand sidebar, the table information section shows us the CANSIM table's number, the number of dimensions, in this case 6, the frequency, in this case monthly, and a couple of other items that we need not worry about at this moment. The table header contains the table's number and title, where we can actually see all of the 6 dimensions. 2 of them, geography and time, are on the axes in the content section of the screen. The other 4 dimensions, labor force characteristics, sex, age group, and seasonal adjustment, are in the filter. Before going on, please take note of the numbers in parentheses beside the geography and time dimensions. These numbers tell us how many members are in each dimension. Thus, in this case, there are 11 members of the geography dimension, Canada plus 10 provinces and territories, and 433 members in the time dimension. Remember that the frequency of the table is monthly. As mentioned, each dimension can contain 1 or more members. When the table is displayed for the first time, all members of the dimensions on the X and Y axes are displayed. However, those dimensions that remain in the filter have only 1 member active. In our case, all geographical data on the X-axis across all months on the Y-axis refer to the entire population, a member of the labor force characteristics dimension, for both sexes, a member of the sex dimension, for all groups 15 years and older, and are seasonally adjusted. In order to see what other members belong to each dimension in the filter, click on the magnifying glass icon by any of the dimensions. For example, labor force characteristics dimension has 9 members, of which 1 has been selected, and so forth. The way the table displays for the first time can also be restored by clicking on Show Table As Is OLAP View in the left-hand sidebar. So if you happen to change things to the point of not being able to recognize what's on your screen anymore and would like to get back to the original state, just click on this option. The next section of this tutorial will show you how to play with dimensions, swap them, replace them, or nest one inside the other. Let's start with something very simple, swapping dimensions on the 2 axes. Just click on the swap icon right above your table's data. Nothing special in here, but on occasion you might want to view data differently than in the original layout. Now we can swap the dimensions back. Assuming for now that we are not interested in data for Canada and all provinces, but just for the 3 prairie provinces, all we need to do is display members of the geography dimensions, deselect all, and select Manitoba, Saskatchewan, and Alberta. Then save our selections, and voila, the display immediately adjusts itself to reflect our selections. Now let's assume that we would like to see data by sex. Remember that the current value for the sex dimension, the active member of the dimension, is both sexes. Since data can be filtered only by 1 member of each dimension left in the filter, we cannot just add males and females to both sexes. We need to nest the sex dimension within the geography dimension first. To do this, simply drag the sex dimension and drop it right beside the geography dimension. Take a look at the screen. Now we can display members of the sex dimension, move males and females to the right-hand box, and save the selection. You can see how the sex dimension with all its 3 members is repeated for each of the selected provinces. The sex dimension has been nested within the geography dimension, or in other words, geography is the outer dimension, while sex is the inner dimension, repeated for every selected or active member of the outer dimension. Now, in order not to clutter the screen up too much, let's leave only males and females and remove both sexes from the sex dimension, but at the same time change the age groups dimension. The latter is in the filter, and the active member is 15 years and over. We first have to nest age groups within the sex dimension by moving the age groups dimension from the filter to the x-axis. You can see now that the sex dimension with its two active members is nested within the geography dimension, and the age groups dimension is nested within, that is repeated for, each selection member of the sex dimension. Now we can go to the age groups dimension, deselect all, and select, say, two members, 15 to 19 years, and 55 years and over. You can see right away that although the 55 years and over column filled up with data, our CANSIM table contains no data for the 15 to 19 years age group. Or rather, we should say, our table contains no data for this particular age group by sex and for the 3 selected provinces. Right, so let's add Canada to the geography dimension, and we can see that although provincial data, again only for the 3 selected provinces for the 15 to 19 years age group, are not available in our table, such data are provided for the entire country. Enough on this topic. By now you should be able to manipulate dimensions freely.